guys, now let's see the code implementation of NOT gate using neural networks. So before that, just understand what is perceptron, because we are using perceptron to design the neural network for NOT gate. So it is the simplest neural network, that is nothing but artificial neural network with just inputs and outputs, which doesn't have any hidden layer. So this is what a perceptron is. This I have explained in the video lecture in detail, so please go through it. The links I have pasted in the description below. So now there is something called a step activation function. So to activate this perceptron, the activation function which we'll be using in our traditional method is step activation function. Okay, now let's see the code. First thing first is to import the libraries. So here I am saying import numpy as np. Okay, so this imports the numpy library, which is often used for numerical operations in Python. Now in this particular code, numpy is not used actually. So this line is optional and can be removed. But it's better to have it so that the computations becomes easier. Now next, let's define our activation function. That is nothing but, as discussed, we are using a step activation function here. Here it takes input z. If my z is greater than or equal to 0, this function returns output as 1, else it returns output as 0. So this function mimics how the neurons fire when the output is 1 and stay silent when output is 0. Now next, let's define the neural network model for the NOT gate. So here I am defining a function which is to simulate a NOT gate using a neural network. Now in neural network, the output is computed as z equals to weighted sum plus bias. So here we saw in the video lecture the weight which is sufficient for NOT gate is -1 and bias as 0.5. So I have just substituted the value in the equation of z, which is equals to -1 into x plus 0.5. So this function returns the z value which is activated if and only if it is greater than equal to 0, or else we get output as 0. Now let's test this. So here I am just writing the testing code, that is nothing but I am passing input 0 to see what will be the output, and next thing what I'm doing is passing input as 1 to see what is the output. So this is a traditional way to code for a NOT gate, where we are manually define the activation function, what is the properties and what is the functionality of it, and then we are manually defining the equation for a neural network to work for a NOT gate. Now that was a traditional way. There is one more way where we just import the libraries like TensorFlows and Keras to build the neural network and then see the behavior of a output which should mimic as a NOT gate. Now let's start coding using these libraries. So okay, first thing, let's import the libraries here. Here again I am importing numpy, which will be handling the arrays for inputs and outputs. Then I have sequential from this TensorFlow Keras models. So this is nothing but the linear stack of layer. Then I have dense. So this dense is nothing but the fully connected layer. Then we have input here, which is used to specify the shape of an input. Then we have optimizer, which we are importing from this TensorFlow.keras.optimizer library, which is nothing but SGD, that is stochastic gradient descent optimizer. Okay, now let's define our input and output, as this is a supervised learning algorithm. So we are just seeing for this input, this is my output. So we are passing the label data here. So this x is nothing but my input, which will be either 0 or 1, and then y will be my output corresponding to 0 and 1 respectively. So now next is what? Let's build a model. So here to build the model, I am creating a neural network with one input node. That is nothing but, since NOT gate takes one input only, so I am taking input as 1, and then one output node with the sigmoid activation function, which gives output between 0 and 1. So this sigmoid allows the network to approximate the binary values, which is 0 or 1 after the training. Now next, let's compile the model, which is nothing but prepares the model for training purpose. So here I am taking optimizer as SGD, that is stochastic gradient descent, which updates weights to minimize the error. Loss function we are taking here is binary cross entropy, which is ideal for binary classification tasks like NOT gate, AND gate or OR gate. And then metrics which we are taking here is accuracy, which shows how well the model is doing during the training part. Now next, let's train the model. So that I am just training it on the set of inputs, that is X, and outputs. Then here I am passing epochs as 1000. That is, the training runs for 1000 full passes through the data set. And then I am taking this argument verbose, which is equals to 0. This will suppress the detailed training log here. Now next, let's make predictions. For that, we say just predictions equals to model.predict here on the input X. So this predicts the output values between 0 and 1 for each input X. Now next, I am just printing the output. Now, as we know, this sigmoid function will give the output ranging between 0 and 1. So I am just defining a condition here, thus the threshold, that if my value given by the sigmoid activation function, if it's greater than 0.5, consider it as 1. So give the output as 1, or else the output will be 0. And then I am simply printing the predicted value and the expected value for the given input X value. So these are two types of ways which we saw to code NOT gates neural network. Now let's see the code implementation of them one by one. So here I am using Google Colab Notebook for running my code cells. So I have copy pasted the first code which we saw, that was the traditional method. So I am just copy pasting that code here, and then when I run this cell, say I will press just shift enter, which is a shortcut to run the cell. You can see for 0 input we are getting output as 1, and for 1 input we are getting output as 0, which exactly mimics the behavior of a NOT gate. Next, let's see the method where we are using this TensorFlows and Keras models for generating this neural network. So I have again copy pasted the second code here, and then I'll just click on shift enter to run this cell. Now let's see what outputs we get out of it. Here we have the output now. See, for input 0, we have predicted output as 1, which is exactly what we expect. And for input 1, we have predicted value as 0, which is expected to be 0. So this is also exactly mimicking the behavior of a NOT gate. So this is how you can write a course using this neural network for all the logic gates. So these sections are important because we have these companies which develop AI models based on the hardware requirements. So there, these questions are asked frequently for the interviews. So it's one of the important topic. Then similarly for AND gate and OR gate with the explanation and their code implementations, I have given the links to those videos in the description below. Please go through it, understand it, and if there are any queries, please comment it so that I can answer your questions. I hope this was useful. All the best. Thank you.